Hello good day viewers. In this tutorial I'm going to take my time to explain the wrong and the right way to solve rational inequalities. We have a problem here, x squared divided by x plus 2 greater than 1. Let's start with the wrong way. The wrong way is by cross multiplication. Do not cross multiply whenever you are given a rational inequality. Please do not. Because let's just do that. By cross multiplication, we're going to take this and multiply by this, right? So it is going to be x squared greater than x plus 2 multiplied by 1. So x squared greater than 1 times x plus 2 is still x plus 2. Then we can take the whole of this 2 times to the left hand side. So we have x squared minus x minus 2 greater than 0, right? We can factorize this. We think of two numbers that can be multiplied to get -2, but the moment you add the two numbers you get -1, and the numbers are -2 and +1. So we have x minus 2 and x plus 1 greater than 0. We're interested in the zeros. By setting the factors to be 0, we have either x equal to +2 or x equal to -1. So if you want to construct the graph of these, you have your root as +2 and -1, something like this. So we have -1 here and +2 here. When we are talking about greater than 0, the values of y are above x-axis, so we need all these values, right? So the solution would be from -infinity way down to -1, excluding -1 because this is just greater than type. But suppose it is greater or equal to, you have to include -1. Union, then from 2 down to +infinity. So this is the solution, the values of x. But you should know that this is a wrong solution. Let me show you the right way to solve it. So here is the right way. The right way is to take all terms to the left hand side. So we have x squared divided by x plus 2 to the left already. As this crosses over, it becomes -1. This greater than 0. But you should also remember that the denominator cannot be 0, right? Therefore, x can never be equal to -2, because if x is -2, -2 plus 2 is 0. We don't want any situation like that. We can rationalize this as 1 divided by 1, or we can simply write x plus 2 divided by x plus 2, right? So we have x squared divided by x plus 2 minus x plus 2 divided by x plus 2 greater than 0. So we can connect the top. So we have x squared. This sign is going to affect the 2 times. So we have minus x minus 2 divided by x plus 2 greater than 0. The top can be factorized as earlier. We have x minus 2 multiplied by x plus 1. The bottom we have x plus 2 greater than 0, right? So this is what we have. There are two different ways to solve this problem. You can either use number line or use those two conditions, because you can see this is positive. It is only positive if both the top and the bottom are positive, or if they are both negative, because negative divided by negative is still positive. But I don't want to use that condition because it is a little bit longer. If you want to watch that method, you can watch the previous lessons. So let's use our number line. The values of interest, we're interested in zeros here. That is by setting these factors to be equal to 0. You have either x equal to +2 or -1, right? And we are interested in this one as well, -2. So we have -2, -1, and +2. Remember that all these three values will not satisfy the inequality, because if you plug in -2 here, the bottom will be 0, and we don't want that situation. And because of greater than type, we are not going to include the roots. These are the roots, right? This and this. So we are going to make a cycle here indicating that none of them is a solution. So let's test some values to the left hand side of -2. We could have -3 here. In between -1 and -2, we could have -1.5. We could have 0 here. We could have 3 here. Let's test all of this. Let's check this one, -3. By plugging -3 here, you have -3, -2, which is negative, right? This is negative. -3 plus 1 is still negative. Then -3 plus 2 is still negative. So you can see that negative times negative is positive, and positive divided by negative will give us negative. So to the left hand side of -2, we have negative. Then let's take this value, which is -1.5. -1.5 minus 2 will give us negative. If x is -1.5, if you add it to 1, you're still going to get negative. The bottom, we have positive because 2 is greater than -1.5. By adding them together, you're going to get positive. So you can see that negative times negative is positive, and positive divided by positive is still positive. So in between -2 and -1, we have positive. Then we test 0. 0 minus 2 is negative because that's -2. 0 plus 1 is 1, which is positive. 0 plus 2 is positive. So negative times positive is negative, and negative divided by positive is still negative. So we have negative here. Then lastly, we check 3. 3 minus 2 is 1, which is positive. 3 plus 1 is positive, which is 4. 3 plus 2 is 5, which is also positive. You can see everything is positive here. So we have positive here. So where do we have solutions? We have a solution between -2 down to -1, and from +2 way down to positive infinity. So let's write it. We have x belongs to the set of values from -2 way down to -1, union from 2 way down to positive infinity. So this is the solution to this problem and the actual valid solution. Let's check that one. You can see that they're almost the same, just that this one started from negative infinity, which is supposed to start from -2 down to -1, then from 2 down to positive infinity. This is how the solution should be. So do not cross multiply. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.